The potential difference between the 2 points in electric field. There are 2 points A and B. The potential difference is the amount of work done we do from this point to this point. If that work done is W and we are carrying the charge Q. So on Q we have done the work W. If we carry a unit charge, the work done will be W upon Q, and this is potential difference from 2. So this will be known as VA minus VB. Final destination, initial point. So this is the potential difference. Now, the unit of potential difference. We are going to use this term a lot. Potential difference, I will write it here. Potential difference is equal to W joule upon coulomb. So the unit of potential difference will be joule upon coulomb, but we are going to use it a lot. So we have substituted it with a derived unit, and henceforth we will call it volt. This is in honor of a scientist, physicist, Volta, who used to do a lot of work in electricity. So joule per coulomb is volt. What is that? Potential difference. The unit of potential difference is 1 volt. What is 1 volt? We will define it here. So, if potential difference dV volt is equal to joule coulomb, if charge carried is 1 coulomb, if charge carried is 1 coulomb, then potential difference volt, then volt is equal to 1 joule. So remember this, when I am carrying 1 charge in my hand and I keep carrying it this way, this way, this way, and I go on counting the work done. Here 0.1, 0.2, 0.3, 0.6, 0.8, 0.9 and 1. I have done from this point to this much. How much work I have done? 1 joule. Name of this point is Q. Name of this point is P. In between, while I was carrying 1 coulomb, I had to do job of work of 1 joule. Therefore, I will say that potential difference between P to Q is 1 volt. Potential difference is 1 volt. When the work done from Q to P is 1 joule, charge carried is 1 coulomb, then potential difference is 1 volt. This is 1 volt potential difference. So now we take it other way. If I tell you that these are the 2 points K and L, L and K, and if I take a charge from this to this, here, there is a potential difference of 3 volt. What does it mean? It means if I take a unit charge from this point to this point, I have to do a work of 3 joule. 3 volt means 3 joule on 1 charge, on unit charge. So now this gives me an equation, and that equation is dV equal to W upon Q, and W is equal to Q multiplied by, let me write it only V for simplicity, and this V now onward we will take as potential difference. Okay, so this is potential difference. If I don't write here A or B, P or Q, that is name of the point, then it will be taken as potential difference henceforth. So work done is equal to Q into V. This is formula for work done. So joule coulomb into volt. Joule is equal to coulomb into volt. Okay, so this you will remember, the unit of potential difference is volt. Now, what are the dimensions? Dimensions will take from its formula, that volt has a formula, joule upon coulomb. Joule is work done, coulomb is the charge. So, dimensions of potential difference. This is equal to dimensions of work divided by dimensions of charge. Dimensions of work is force into displacement, that is ml2 t minus 2, and this has got ampere into time, at. So this is ml2 t minus 3 into a minus 1. ml2 t minus 3 a minus 1. These are the dimensions of potential difference. So this is the unit, this is the potential, and this is fundamental basic formula, and on the basis of this formula you will be solving many numericals. So we have started making formulas of potential difference. This is the fundamental formula. Work is equal to QV, or V is equal to W upon Q. So we will go on making a formula bank here. V is equal to W upon Q, or W is equal to Q into V. So after that we will find its relation with the electric field in which it is there. Thank you.